In this video, we are going to learn how to find the distance between 2 points. And to introduce how we're going to do that, let's look at an example. Find the distance between the point A, which is -2, -1, and B, which is the point 2, 2. Let's draw a picture of these points. So let's say I have the origin here, and A is -2, -1, here. And then B is 2, 2, which is here. And I have this line segment from A to B. And I want to know what's the length of that line segment. That's the distance from A to B. Well, the idea is to take my point A and draw a horizontal line through A. Draw a horizontal line for A, get this. And if I take B and draw a vertical line through B, I get this. Now notice, what did I just drew? I drew a triangle. I have this triangle here. And this isn't just any triangle, because what's the angle here? It's a right angle, right? A horizontal and vertical line make a 90-degree angle. So this is actually a right triangle. Let's call the point where this horizontal and perpendicular line intersect C. Now, what are the coordinates of C? Well, from B, C, to figure out what C is, I need to figure out how many units to the right and how many units up or down, right? Left or right or up and down. And C is to the right of the origin by how many units? Well, C is directly below B, and B, the first coordinate is 2. The x-coordinate of B is 2. Therefore, the x-coordinate of C must also be 2. Remember, all the points on this bluish, this kind of greenish line have the same x-coordinate. And similarly, all the points on this kind of mahogany color, reddish brown horizontal line through A have the same y-coordinate. And the y-coordinate of A is -1. Therefore, the y-coordinate of C must also be -1 because A and C are on the same horizontal line. Okay, now let's apply what are we going to do? We're trying to find, we have this right triangle, and we're trying to find the length of the line segment from A to B. Well, that's the hypotenuse of the triangle. We're trying to find the hypotenuse of the triangle. We can use the Pythagorean theorem. And to use the Pythagorean theorem, we need to find the lengths of the two legs. So what is this horizontal distance here? That's AC. Well, I went from -2, -1 to 2, -1. So I went to the right 4 units, right? It's 2 minus -2 is 4. If I take the absolute value. Okay, so I subtract the x-coordinates and then take the absolute value. And similarly, to find the distance from B to C, I can just take the absolute value of the difference of the y-coordinates. That's 2 minus -1, that's 3. Okay, because I went, 1 unit here and then 2 units here, that makes a total of 3. Here I went 1 unit, here I went 2 units, here I went 2 units, here I went 2 units to get from A to the y-axis, and then 2 units to get from the y-axis to c. So I get 4 for AC. Okay. So by the Pythagorean theorem, AC squared, well, that's let's see, no. The hypotenuse is AB. When I square it, that's the hypotenuse squared, that's AC squared plus BC squared. So AB squared, okay, I'll just put parentheses just to make it clear that we're taking this length and then squaring it. It's AC, that's 4 squared, plus BC, that's 3 squared. So AB squared that's 4 squared plus 3 squared is 25. AB is a positive number, therefore AB is equal to 5, which is the square root of 25. And we can find a general formula using the same method. So pretend that A is here, say x1, y1, and let's say B is here, which is x2, y2. Now we don't know what x1, y1, and x2, y2 are. Okay, I'm just saying, suppose you have 2 points, and they don't have to be on the third and first quadrants. I'm just drawing a picture. So you have something like this. You can do the same thing. You just draw a horizontal line and a vertical line, and then drop a perpendicular, and they make a 90-degree angle, and you can use the Pythagorean theorem. Now, what is the horizontal and vertical length? Well, for this horizontal length, all I'm changing is the value of x. And so I want to see how much did x change. Well, the coordinates of C here are, what are they? Well, C, if you compare what we had above, C has the same x value as B. So the x coordinate of C is x2, and similarly, C has the same y value as A, so this is y1. Okay. So the coordinates of C are x2, y1. Now what's the horizontal change from A to C? I just changed horizontally the value of x. I don't change the y coordinate. How much did the x coordinate change? Well, that's going to be the absolute value of x2 minus x1. Right? Because the absolute value of x2 minus x1 is the distance from x1 to x2. And similarly, when it comes to this coordinate here, at this length, the only difference is the change in y, and it going from B to C, there's a change from y2 to y1. So what is the distance? That's the absolute value of y2 minus y1. So the Pythagorean theorem says, by the Pythagorean theorem, AB squared is equal to AC squared plus BC squared. AC, we know, is the absolute value of x2 minus x1. BC is the absolute value of y2 minus y1. Now remember, why are we putting absolute values? Because in this picture, x2 was bigger than x1 and y2 was bigger than y1. But in general, they don't have to be. So you need absolute values to make sure it's positive. Okay, so that, and now how does that simplify? Well, when I take the absolute value of x2 minus x1 and I square it, that's the same as just taking x2 minus x1 and then squaring it. Because when you take the absolute value, all you're doing is you're multiplying. You're either not changing the number, So when I take the absolute value of x2 minus x1, it's either x2 minus x1 or it's negative parentheses x2 minus x1. But when you square them, you just get x2 minus x1 in parentheses squared. Similarly, I am going to get y2 minus y1 in parentheses squared. So this was ab squared. And therefore, ab is, notice I have a positive quantity ab, so I can just take the square root of both sides. I'm going to get x2 minus x1 squared plus y2 minus y1 squared. And that's a formula that's called the distance formula. So let's write down the distance formula. Distance formula. The distance formula says that the distance between 2 points, A, which is x1, y1, and B, which is x2, y2, is the square root of parentheses x2 minus x1 squared plus y2 minus y1 squared. The important thing to remember is how we got the formula. And basically, in one sentence, all you do is you make a right triangle using your 2 points, and then find the hypotenuse using the Pythagorean theorem. That's, in one sense, how you got this formula. And see, if you look at the formula, it even just looks like the Pythagorean theorem, right? That kind of makes sense because we use the Pythagorean theorem. So let's do a quick example. Find the length of the line segment joining J, which is negative 4, 3, and K, which is 2, negative 1. Now you could, if you wanted to draw a picture and label the points J and K, but since we have the formula and the question is asking for the length, let's just use the formula. So we need an x1, y1, and an x2, y2. Well, let's take J to be our x1, y1, and K to be our x2, y2. Now it doesn't matter which one is your x1, y1, and x2, y2, because you're just finding the distance between 2 points, right? And you know, if you're finding the distance from J to K, that's the same as the distance from K to J. I mean, so it doesn't matter which one. There's nothing wrong with, so you could make J your x2, y2, and your K your x1, y1. And if you actually, I would encourage you to actually plug in the numbers and see that it doesn't matter either way. Okay, but let's just use J as K1, J as x1, y1, and K as x2, y2 because J came first. So then the distance JK is equal to the square root of x2, that's 2 minus x1, that's negative 4. And now this whole thing is in parentheses, squared plus, and then y2 is negative 1, and then y1 is 3. And then you square that. What is this equal to? It's the square root of 2 minus negative 4 is 6. 6 squared is 36. And then negative 1 minus 3 is negative 4. Negative 4 squared is 16. Square root of 36 plus 16 is 52. And now it might be a little better to simplify this all the way. 52 is 4 times 13. And so this splits as the square root of 4 times the square root of 13. Square root of 4 is 2, so 2 times the square root of 13. And that's the answer. Okay, so just to summarize what we did in this video, we prove the distance formula. If you have 2 points and you want to find the distance between them, just make a triangle with them and then find the hypotenuse. And when you do that, you get this formula, which we applied to a problem. And it's okay if you don't remember the formula. I usually don't remember. It's not like I actually practice memorizing this formula, that it's this. Okay, I don't make a big deal out of that. Just if you have a situation where you have to find the distance between 2 points, just draw the triangle and then figure it out from there. I think that's actually easier than memorizing the formula. So just memorize the method, not necessarily the formula. Okay, thanks.